Okay, so the next sorting algorithm we're looking at is insertion sort. This algorithm is the first one to be somewhat different from that bubble sort form. It works by splitting up the list into two halves again, with the first half being ordered and the second half being unordered. It starts with the first item in the list being considered to be in order. It takes the second item in the list and looks at the first item. If it's larger, it stays where it is. If it's smaller, it swaps them around. It then moves on to the third item, again compares it with the second item. If it's larger, it leaves it where it is, otherwise it swaps them around, and then compares it with the first item and repeats the process. Okay, so you get how it works looking at this graph, so let's code it up. The first thing we're going to start with is a for loop with an index, and we're starting range, and we're starting at 1 because we're looking at that second item in the list and comparing it to the first, and we're going up to the length of the numbers array. So numbers length. So we're going to get the value of the item we're looking at, which is current value equals numbers I, and we're also going to get the position that we're swapping with. So position, now we have our first while loop, and we're going to go while position is larger than 0, which is of course the first item in the array, and the number at that position is larger than the current value that we're looking for a position for. Move the number in that position, in front of that position up 1, essentially moving it forward, making a space for our number. So numbers, and of course, because we're moving forward through our array, we want to decrement our position number by 1. So the final thing, what we want to do is when we exit out of this for loop, it means we've found our position in the array where our number can fit. So we want to put our number in there. So numbers position, and we're going to put our current value in there to finish up our code. So let's run it and see how it works. There you go, we get an ordered list. Like all the other algorithms that we looked at, this has an efficiency of n squared, but because it works slightly different, some cases it might be more efficient because it's only performing one comparison between picking the number and inserting it into the new list. In the next video, we'll be covering a vastly different type of sorting algorithm, the shell sort.